Hi everyone, welcome to this episode of Hands On with AI Agents. Now, in this episode, we have an interesting topic for you. It's how to build a full blown data science agent. Let's hear more from Melton. Hi, Melton.
Hi, Sita. Thank you so much. And hi, everyone. I'm very happy to be here and very happy to be able to walk you through the data science multi-agent system that we built, as Sita mentioned, on our open source Google ADK. So, yes, let's jump right in.
Yeah, what do you have for us?
I came prepared, so we're doing a lot of technical hands-on stuff. But before we dive into the fun part, I wanted to briefly touch up again on the intro, like what are agents, where did we come from, and where are we now with agents. A very brief refresher on the agent development kit as well. Then I'm going to walk you through the architecture of the data science agent. And after, we're going to see the fun part with the technical deep dive.
Okay, can't wait. Let's get started then.
So as for the introduction, I just want to very quickly iterate on where we came from with generative AI and where we are now. So when we started in the early days, there was mostly just LLMs and prompting. You may remember these days, right? And then there was the hot topic of RAG pipelines being the next big thing. So everyone was building their RAG pipelines to connect to external knowledge sources so that the LLM is a bit more useful. What came afterwards is then adding function calling and tools to the LLM. So we had then now, which you see in the model, the LLM, we had the RAG pipeline, and then we had the tools that we essentially hard-coded to the system for it to do stuff on our behalf. The next evolution, and this is where we then come to the agents, that's the container that you see in the slide deck, is essentially having these components, the same components, the LLM, the RAG pipeline, the tools. But now we have a bit more sophistication behind it because now the LLM agent is doing the reasoning and planning. It knows when to execute the tools, and it's also handling the session and the orchestration. And the last thing that you see here is moving from a single agent to a multi-agent system. So now you also have to orchestrate not just one single agent and its tools, but also the communication between the different agents. So to summarize again, what is an AI agent? An AI agent helps you plan, reason, and execute to do certain tasks on your behalf. So as I mentioned for the container that you remember from the previous slide, it comes with orchestration as well. So it has memory, it handles the session for you, it has the reasoning and planning capabilities as well, so that it really knows how to execute a plan and when to use the tools that you provide to it. And also in the multi-agent system, when to route and when to call other agents as well. In the second part, I want to give an overview again, very briefly, on the agent development kit. We have another video series just on the agent development kit and also building your Hello World agent on top of it. So if you haven't seen it, I highly recommend that you take your time and watch it, because here I'm just very briefly walking through the stuff as a refresher, and we will focus mostly on the data science agent. So just as a refresher, the ADK is a client-side code framework and SDK to build sophisticated multi-agent solutions. So it helps you by providing all of the necessary things you need to build multi-agent systems. It handles a session for you. It makes it very easy for you to set up your agents and to set up agent tools and multi-agent systems as well. So it's a very, very helpful resource to get started with multi-agent systems. The tools that come out of the box with the ADK are function calls. You can also insert retrieval tools, like for example for your files, Vertex AI Search or Vertex AI RAG. And the very neat thing here is as well that you can create base and custom tools by extending the base tool class. All right, before we dive into the code base, let me walk you first through the architecture and let me briefly walk you through each of these agents and what they do. So starting from the middle with the database agent, as you can guess, the database agent is there to handle the NLToSQL workload, meaning it translates the user query into the proper SQL to query the database. It's also the one agent that has the tool connected to our BigQuery dataset to execute the SQL and to retrieve the data for us. And it comes with a SQL validator and fixer as well to make it a bit more robust. What we've integrated in the code base are two methods to build the SQL. The one is by scratch using Gemini. This is what I'm going to show in a bit more detail. The other thing that you can also play around with is Chase SQL. So Chase SQL was a paper from Cloud AI Research that was published a while ago. And they really came up with a method to properly and robustly build SQL from natural language queries. And this was also the method that is on the higher ranks on the BERT leaderboard from our own Cloud AI organization. So Chase SQL code is there. You can play around with it, but we won't be going too much into detail in this session. The other agents are the data science agent that you see at the top. The data science agent, as the name suggests, does the NL to Pi workloads. So it's there to do analysis. It can generate plots. It can essentially just execute Python code to help with everything on top of NL to SQL. This works with the code interpreter extension. We'll also see this in a bit. Then we have the BigQuery ML agent at the very bottom. So BigQuery ML agent is there to support with a bit more sophisticated data science workloads. Everything that you can do on BigQuery ML, you can do with a BigQuery ML agent. It's really there to give kind of support. It can write the BigQuery ML SQL statements. So you can really use it to train models, use them for inference, and do other sorts of analysis. And everything comes together with what we see on the left-hand side with our top-level data agent. That's our root agent, which is coordinating the complete flow. It's also the one communicating with the user. The root agent is tasked with orchestrating the query to the different data sets, to the different agents, meaning that if it sees I need to route this to the database agent, then it does so. We're providing here, as you can see, the top two agents, so data science agent and the database agent as tools, and the BQML agent as sub-agent. I'm going to show this in the code base, and you will see why we're doing this. So this all has its reason behind it as well. Then lastly, the data sources that we connect to it for the sample is using BigQuery. You are free to extend this with whatever database you have. But for our showcase, this is the one that we chose and that we're going to stick to for the code walkthrough as well.
This is a great walkthrough, Meltem. Like seeing all of these components together in an architecture really simplifies things. And I had the same question too. Why do we have agents as tools and sub-agents? But I'll hold on to that until we get to the next section. Now, I have another follow-up question though. Can you help us with a sample prompt that you would give to the parent agent that maybe uses one or more of these agents just to tie things up together?
Of course, we'll see a lot of this in action at the demo section, but essentially how all of this works is that the root level agent is the one that's being exposed to the user, so it handles the user communication, and the root level agent then routes to the other agents whenever needed. So let's go with an example prompt. Let's say you just want to explore your database. So you ask something like, how many rows are in my train table, for example. When you ask this, what the root agent does is it's passing this query to the database agent. The database agent then generates the SQL for this. It executes it against BigQuery. It fetches the data and then brings it back to the root level agent. And the root level agent can then generate an answer and provide it back to the user. Also, in here, it's the root level agent that's assessing. In this case, for example, the data science agent was not needed to answer the question. So it knows I don't need to invoke it. But if the user asks questions like, can you generate a plot of total sales per country, for example, it also executes the data science agent, meaning it goes the same flow again, the database agent, but then it also is able to consolidate and fetch the data, pass it to the data science agent to generate the code and execute it, and then bring everything back to the user to show the plot and provide an answer back.
Wonderful. And now for the most exciting part of the video, can we jump into the code?
Of course, more than happy to do so. So let's dive right in with the technical deep dive. All right, and with this, we're finally at the fun part, looking at the code base. So what you see here now is my VS Code environment, and I want to walk you through how things are set up and how things are working. So if you want to do this and test it yourself, we're going to show you later on where you can find a repository. And we have a very detailed README for the data science agent setup. So just follow the README, set everything up, and then you should be at the same stage that I am to be able to play with the data science agent. Before we go into the demo and see everything in action, I want to walk you through really the core backend and how everything works and how everything comes together. So the starting point in the repository for us is inside the agents directory in data science. What you see in the data science directory is another directory called data science. This is where the magic happens. So this is where the agent code resides. And if you inspect this directory, you'll see that we have agent.py, instructions.py, and tools.py directly in the data science directory. So this is what we need for the root agent. And I'm going to walk you through each of these files in detail. All right, I would now start with the agent file first, because this is where we're using the ADK to really define and instantiate the root agent. This is happening by importing from agents the class agent. And you'll see that it is very easy to get going and set up your agent class in here. So we have the root agent, we instantiate the agent class, and then we just simply need to pass a few configuration parameters, which are the model that we're using for this agent. So in this case, we chose Gemini 2.0 Flash. Then we have the agent name. For our root, that's the DBDS multi-agent. We have the instruction. You'll see that I took them out from the instruction.py. Reason why we outsource the instructions and the prompts in here is simply for to make things a bit more easy, because you're going to iterate on the prompts, you're going to do prompt tuning as well. So it's easier to keep track of the changes if we outsource it. But you'll see the setup of the file also in a bit. Then we have the global instruction. So the difference in here, you may wonder, between instruction and global instruction is simply that instruction is specific to this root agent. So no other sub-agent is going to see this specific instruction. Global instruction, on the other hand, are kind of like a global context. So each of the sub-agents is also going to have this information. Hence why we kept it very limited in our case, because we have very explicit instructions for each agent. And we're passing the date of today because we want all of our agents to be aware of today's date. All right. Next up, we have the sub-agents and the tools. So if you remember the architecture, this is what I mentioned. We have the BQML agent provided as a sub-agent, but we also have the DB agent and the S agent, but those we are providing as tool. I'll come to load artifacts in a minute because that's not an agent, but essentially just also for the reason why we chose this setup. The difference between sub-agents and agent as tools, as we provide them here, is in how the orchestration is being handled. Meaning, if the root agent is our main point of contact, what happens when we provide agent as tools is that the root agent is invoking these tool agents, passing the task to them, they're doing their thing, and then they always get back to the root agent. So it's kind of outsourcing the task to the agent tools. And then you, as the user, continue to have the session with the root agent. Whereas with the sub-agent, that's kind of more routing the conversation. So in our case, why we chose to do this was because usually you do your analysis, your data exploration, and then at some point in time, you want to move over to more sophisticated data science workloads. And if we were to pass the BQML agent as a tool, that would mean that we would always need to switch back and forth between the root agent and the BQML agent. Whereas if we pass it as sub-agents, what happens is that the root agent is giving over the conversation fully to the BQML agent. And I, as a user, am now conversing with the BQML agent. We can always revert back as well. Like have the BQML agent transfer back to the root agent if it identifies that we, again, revert to NL to SQL type of questions. But it stays with the BQML agent for everything that is BQML related. Let me pause here and Sita, ask you as well if this has been clear or if there are still any questions on this.
So you mentioned, Meltem, about the load artifacts. Can you briefly talk about that a little bit more?
Yes, I can. So why I didn't go into detail was because the load artifacts is, as I mentioned, it's not an agent tool. The load artifacts is a Python function that we provide to the root agent as a tool. And you'll see that in a bit. It's helping us with managing the artifacts that are generated in the complete multi-agent flow. So meaning, let's say, for example, you're querying the data science agent, or rather the analytics agent, which is the NL2Py agent tool that we provided in here. And this one is generating a plot. We now need to somehow handle this artifact, the plot, in our session as well. And we want to make sure that we are properly showcasing it back to the user. That's what the load artifacts tool is doing.
So instead of having an external service where you could actually store these artifacts, you'd have to write your own custom code. You're saying this is a pre-built tool that we can leverage to just store artifacts and then use them whenever we want. Is that right?
Yes, so the ADK comes with simplified mechanisms to handle the artifacts that are generated when you're using the agentic workflow. That is correct. Okay. Another very cool feature that we have in the ADK is the before agent callback. It is, as you can see in here. So this is defined in here as well. So we have set up before agent call. And if we go a bit up in here, what we see is a few lines of code setting up the agent. Let's inspect what's happening here. So essentially what we do is we're invoking this code before we're invoking the agent. So this is something that you can set up as control mechanisms as well as a developer. So we have both the setup before agent call and setup after agent call, which essentially enables you to do some stuff first before the agent is being called. And likewise, handle the output with a more deterministic code flow as well. So let's say you also want to make sure that certain things are filtered in the agent response. You can do that by invoking the after agent call method in this scenario. We're not doing that, we're just doing the setup before agent call. And what's happening in here is, as you can see already with this one, we are providing the BigQuery schema and DDL details upfront to the agent. So we're essentially making it a bit more data aware by really telling it, the root agent, this is the data set and the database we have access to, and these are the tables, these are the columns in a data set. With this, we also want to ensure that it's a bit more efficient, because for kind of schema-related questions, we also don't want to always invoke the database agent and always generate a SQL and then always execute it. That way, the root agent also has this information and can just provide answers for schema-related questions. So we're doing this in here by setting these relevant details in our context. So we have the callback context, where we are storing the things in the OLDB settings. And specifically in the use database, we define that we are using BigQuery. In this scenario, we are providing the database settings with a tool that we are invoking from the BigQuery tools, which, as the name suggests, retrieves the BigQuery database settings. And then we're storing the BQ DDL schema as well in the context state. And that afterwards helps the agent to be aware, as I mentioned. Let me pause here again and see if there's anything unclear with the callback context.
Yes, thank you. So what you're saying is we can also use this as a tool. The agent can have a tool which can get the schemas and then feed it. But we are optimizing here, is what you're saying. Even before you make the call to the agent, we're going to fetch all of the schema and all of the info and pass it to the agent to optimize the workflow. So if the agent has all of the necessary info, it can immediately answer the user prompt. Is that right?
it is making things a bit more, it's giving a bit more control even. Because if you think about the tools and how they're executed, you're giving the control over to the agent, right? Because the agent is reasoning about when to execute certain tools. With the callback context and the setup for agent call that we're doing here, you all ensure that this is always happening. So it's not the agent that's invoking it, but every time that the agent is being called, you run these things first. So that's kind of a pre-setup stage that's a bit more deterministic, where we have a bit more control that we can implement in here. And the same thing goes for the agent call, like after agent call setup that you can implement.
Okay, this is clear. So it's to introduce a bit more control and determinism into the workflow. Sounds good.
Absolutely. All right, so that's for the agent.py. That's the core logic where we're instantiating the agent. I touched on the instructions of Py as well. As you can see here, and let me maybe close that one. We have the prompts and the instructions of the root agent outsourced. And you'll see the same pattern for the other agent tools and the sub-agents as well. So why we're doing this is just to, as I mentioned, make our lives a bit easier, because you can see here that I can just iterate on the prompts. I have earlier versions of the prompts as well. So they're still there. I can still use the prompts I used back then. They're not gone, like I'm not overwriting them. And what we then have here is the instructions specific to the root agent. So we are giving a few instructions and notes on what the agent should consider. And we are giving the instructions on the tools along with it as well. So how the ADK works is it also knows about how the tools work from the doc string. So if you have, of course, a clean setup of your functions with a proper doc string, you won't need to excessively prompt in here. In my case, what I'm doing is I'm just giving over a quick overview of the workflow, because I want to ensure that the DB agent is called first to retrieve the data before the DS agent is being executed. So you can see that and let me move this out of the way as well. You can see that I am defining the workflow. Essentially, first make sure that you understand the intent, then that you come up with a plan and know what you need to do. Then retrieve the data with the callDB agent tool. If you need to, that's also one caveat in here. So you may not need to do it. It may be the case that you saw that we provided a schema as well to the root agent. There may be questions that the root agent can answer directly, so there's no need to unnecessarily invoke another tool or another agent. Likewise, the same thing for the DS agent. So we're saying first retrieve the data. Then if you need to call the data science agent, make sure that you do it after retrieving the data and that you're passing all of this to the data science agent as well. And aside from that, also make sure that you transfer to BQML, meaning that you can see here, if the user specifically asks for any BQML related workloads, use this one. Make sure that you route to the sub-agent with this. And then we have a few other key reminders. I don't want to go too much into detail in here because you have other instructions as well to look out for, but make sure to play around with this. And you can always optimize the prompt or edit it to make sure that it works for your use case. The instructions.py files are where you will find the prompts for each of these agents. Okay, then the last file, as you recall, is the tools.py that we also had in here. This is also related to the root agent, which is living in the main data science directory. So let's move over to the tools.py file. Quickly stopping in here. Do we have any questions?
I think the instructions file is even more lengthier than our agent.py file, like with most of our agents. But how important is to write good instructions for an agent, Malcolm? And have you tested by passing different variations of these instructions with this agent?
I have, and it's the same as it has always been with LLMs. So you want to make sure that you invest in your prompts and that you do prompt tuning and prompt optimization as well, because they're important. Like from our experiments, what we saw, especially with the latest Gemini releases, 2.0 and 2.5, is that it's considerably more robust than it was before. But nevertheless, and this is true for no matter what LLM you're using, make sure that you don't have any contradictions in your prompt. Make sure that, what I always tend to say is make sure that your prompt is human readable. Because when you as a human read it and you don't understand what's going on, don't expect the LLM to understand what's going on. So make sure that it's clearly formulated, everything is concise, no contradictions, and then you should be good to go. All right, let's now look into the tools as well. So these are the tools for the root agent. If you recall, these were the agent tools for the database agent, as well as the data science agent, and the load artifacts tool. So we have the async call here to the DB agent, where we are essentially doing a bit of pre-processing as well before we invoking the agent tool. The main invocation happens here. As you can see, we're doing instantiation agent tool for the database agent, and then we're doing the await run async method, which essentially then runs this agent tool. Now we're providing this back to, which happens automatically to the root agent, but we also make sure that we store the DB agent output in the tool context state that you may recall that we've seen for the schema storing as well. This helps to make sure that it's also a bit more efficient. Like if you retrieve data already for answering a user question, the agent now doesn't need to do it again because we have stored the data output and the SQL in the context state. So it makes things a bit more natural and a bit more efficient in converging with the agent.
So, Malcolm, can you explain a little bit more about what tool context is?
Yes, of course. Similar to the context that we see in, like for, let's say, for the session context where we store the stuff. The tool context is context that we can specifically pass to make sure that we're storing whatever's happening with the tools. So as I mentioned, let's say in this case, you're running the database agent. You want to make sure that we're executing this tool. So the root agent is invoking this tool. And we want to store the output of the tool in this context so that we can also fetch it again at a later time whenever it's needed. So it's just another kind of short-term memory handling where we're storing a bit more of the information in the context of the stuff that has been happening. All right. Then very similarly, same structure for the call DS agent. As you can see, we have the async function in here as well. We are providing a bit more detail in here compared to the DB agent because we're giving the question as well in a kind of in the instructions to the DS agent. And that's a key difference. Actual data to analyze from the previous question is in the input data. So this is where now we see it in action with what I now answered for the tool context. We stored the previous response and the data executing the database agent in the tool context. And now we can retrieve this inside the data science, the DS agent, to make sure that the DS agent has access to this context when it's creating its Python code and when it's running its analysis. So this is how everything comes together in here. And then a similar structure where we instantiate the agent tool and then run the async call as well to the tool, which then essentially invokes the tool. So this is where the run is being executed. And as you can see here, so we prepared the string with the input data and the question. We can pass it in here for the request. And we're also providing the tool context where we stored the DB agent output and also where we're storing the query result. Is there a question?
Yes. Is it fair to say the tool context is almost like a short-term persistent context that you can provide to each and every tool? Like each and every tool has access to it by default. So if one tool stores an artifact or a key variable inside the tool, every other tool would have access to it.
Yes. So it is short term. I want to be cautious with persisting. So it's persisting over the current session, but then it's going to vanish. Yeah. But it is essentially, yes, short term memory in a way for everything tool related. Okay, now this concludes for the root agent and how things are set up. So you get the gist, right? We have the agent.py with the core ADK logic on setting up the agent and the configuration. We have the instructions.py where we outsource the prompt. We have the tools.py where all of the tools are stored that the root agent is using. And you'll see once you go into the sub-agents that these are following the same structure. So we have, for example, in the BigQuery agent, the agent.py, instructions.py, and tools.py. And the same thing for the BigYAML agent. So the format is always the same, which also makes it easier when you're exploring the code to follow along and to modify the prompts because you'll always find them in the instructions.py. All right, let me take the rest of the time to quickly go through the other things that we're building in here and how these flows come together. So let's start with the BigQuery agent. This is what I mentioned in the architecture, if you recall. We have two methods of SQL generation. First one being native with Gemini, and the second one using JSQL from our Cloud AI research organization. So I'm not going to cover JSQL in detail, but I would recommend you to try it out. You can simply set the method of NL2SQL generation in the environments file. So just switch it out to Chase, everything's documented in the README, and then feel free to play along with it and see if this is helping you with more complex SQL generation use cases as well, because it performs better than just the standard native Gemini SQL gen that we've implemented. But in our scenario, we have now the BigQuery agent as tool that the root agent is using. And also very quickly in here, it's the same setup, right? So it's also very easy to set up the agent tools, the sub-agents. They're all following the same pattern. We have the agent class that we're importing, and then we just instantiate it with the configs. Model, name of the agent, the specific instructions just for this agent tool, sub-agent, whatever it is. We have the tools again. We have the before agent callback again. So you see that you can set up the tools. You can set up agent callbacks before and after for all of the agents you're defining. These are not limited to the root agent. These can be also used for the agent tools, what we see in here, as well as the sub-agents that we connect to the root. So as you can see, it's the same thing again, and it's very easy to set up the agents. You can follow the same pattern to extend it as well. Like, for example, if you want to include another type of agent into this, one for question answering over PDF files, for example, you can just follow the same format, set up another agent, be it as a tool or as a sub-agent, depending on what is your need for a use case, and then just provide the agent.py with these lines of code, setting up the agent, the instructions, as well as the tools that you need for your agent, and you're good to go. Then the only thing that you need to do is for the root agent to go back and edit either as a tool or as a sub-agent into the list, and everything else will be handled automatically by the ADK. So it's also very easy to extend the agentic workflow to with additional features and additional use cases as well. Okay, I will not go into all of the prompts in here. So as I mentioned, feel free to check them out. They're always in the instructions, and they're all following the same pattern as well. All right, then with this, that concludes for the code base. What I now want to do is I want to show this agent in action. And to do it, we're spinning up our terminal in here. We're making sure that we're navigating to the data science repository. So see the agents, data science. And then, and that's another very cool thing, the ADK comes with its own developer front end. So all we need to do, once everything is set up, we just run the command ADK web. And then you'll see that it's going to spin up an Angular front end for me. And I'll be able to interact with this complete multi-agent system.
And the cool part is you didn't even have to write any streaming code to handle this. or you didn't have to write any front end or client facing or anything. It's all built in within the ADK, and we're just invoking it with this one command.
That is true. You'll see all of that once I spin up the front end. And here we are. So this is the front end of the ADK. When you're running the ADK web in the terminal, this is what is being spun up. You can just go to your local host and you'll see it. And the first thing that we're doing, so we're invoking the ADK web command inside the data science directory, not the second one, the first one at the very top. And then we're being able to select the data science one, where, if you remember, the core complete agent backend logic resides. So we're just going to ahead and selecting this one. And then we're good to go. So when we now go ahead and chat with the system, what is being done is we're then interacting with the root agent. But before I do it, let me also walk you a bit through the UI, what you see here. So you'll see all of the events in here once we start conversion with the agent. You can also always inspect the sessions and store them so that you can get back to them. You'll see artifacts generated in here. I'll show you this one as well once we created a few of them. And there's another tab with the evaluation. I also recommend that you play around with this as well, because if you have a session, what you can do is you can create an evaluation set automatically handled by the ADK, and then you can use this evaluation set down the line again, spin it up to evaluate your agentic system if you made any changes. So the other evaluation set, which is not referring to the ADK, but more to the data science use case itself, is first for the NL to SQL one. For that, we have, as I mentioned, the chase SQL method of generating the SQL as well. That's the one from Cloud AI Research. And you'll see that it is currently inside the BERT leaderboard top 5. So you can check out the leaderboard there, and the BERT set essentially is a test and evaluation set for NL to SQL performance. The other thing is for the data science evaluation, what we did as well, and you can check this out in the specific highlight overview of the data science agent, which we're also going to link in the resources. You see a video where we showcase essentially the full BQML steps of training a model for a Kaggle competition. And you'll be able to use the BQML model in here to very quickly get you going, set up, in our case, an ARIMA model for forecasting in just a matter of a few minutes. And then you can use the model to do inference and even submit to Kaggle leaderboards. So we managed to get to the top 30% in about 30 minutes using just the BQML agent. And also, honestly speaking, I'm an absolute noob when it's really coming to BQML because I haven't played with it before. So I was able to get this running in 30 minutes without any BQML knowledge whatsoever. But that's for the evaluation. And I will now show you our data science agent in action. So let's just start querying. What data do you have? You'll notice that the first prompt that you're sending takes a bit longer than the rest, simply because when you haven't set up the code interpreter extension, it's spinning this up for you. In my case, it was working a bit faster because I already have the code interpreter extension set up. So what we see here is I have access to data about sticker sales, which is the data that we provided in BigQuery. And then it's giving me information about tables, which is evaluation set, test, train, and train full that are in my BigQuery. And the information inside these tables being date, country, store, product, and number sold for each transaction. You'll see that it retrieved this answer without invoking any of the agent tools or the sub-agents. Because if you remember, we passed the DDL schema, like the complete table and column schema, to the root agent as well. So it can answer these questions without adding latency on top of it. But let's go ahead and ask a question where we need to invoke the database agent. So let's say, what countries exist in my train table? What you see now happening is we see in the front end the full trace of what's happening inside the agentic system. So the root agent has now invoked the calldb agent. Now it got the response back from the calldb agent tool, and it's providing us with the response. What you can now also see in here, we have the events tracked as well inside the UI on the left-hand side. We can also additionally inspect the traces in more detail, so we can see how the calldb agent tool was invoked. We can inspect the JSON and see exactly what question the root agent passed to the database agent tool. So you'll notice that I asked what countries exist in my trade table. And the root agent reformulated this question and passed it to the database agent saying, what are the distinct countries in the trade table? And what we then get from the tool execution is the response from the database agent, where we then see the explanation of what it did. We get the SQL that's generated back from the model, and we also get the data back. So these are the SQL results that we get once we execute the generated SQL against BigQuery. And with this information, the root agent then comes up with the answer to the users. Okay, then let's continue with another question. Let me close this one right here and maybe also close this one so we have a bit more space. Let's ask a question that needs to invoke the data science agent, like the DS agent tool, because we have the complete data science agent in here. So to invoke the DS agent, let's just say I instructed to generate a plot of total sales per country. So let's say generate a plot per total sales. Oh, sorry, with total sales per country. Again, and this is the correct workflow, it's first invoking the database agent because it needs to retrieve the data. It gets the data and the responses back, and then it's invoking the analytics DS agent for the Python workload. And what this agent is then doing, it's going to write the Python with the data, if you remember it, that we passed in the tool context, where we stored the output from the DB agent. The DS agent has access to it now, the data, and it's generating the plot for us. There we go. It's a bit small here, but what you can do is you can open it in a new tab and inspect it in detail. And you see that I got the total sales per country back in here. So we have the countries Canada, Finland, Italy, Kenya, Norway, and Singapore, and it plotted it for us. Let's move back. It's also giving the result in natural language again for us, along with an explanation. And if we now open the artifacts tab, you'll see that it's storing all of the generated artifacts in the session for us. So this is the load artifacts tool that's being baked into the ADK. That's making it easier for you to handle all of that. So you don't have to think about all of this artifact handling and plotting. All right, then let's try one last query, and let's try to invoke the BQML agent. So if you remember from the prompt, this is explicitly set to only be invoked and transferred to if the user says, we want to now work on BQML workloads. So let me say, I want to train a forecasting model using BQML. And as you see, what the root agent then does is it's transferring the complete session over to the BQML agent. So it's now the BQML agent that I, the user, am talking to. And what the BQML agent is doing, you can see it in the tools as well. Once you inspect the tool set that the BQML agent has access to, it is connected to the BQML reference guides and can do RAG invocation. So it's just doing retrieval augmented generation to query these reference guides for BQML so that it knows the proper BQML syntax as well. And then it's directly suggesting us that the BQML reference guide is saying, okay, for forecasting, I would recommend the ARIMA Plus XRAG model in BQML. it requires these kind of data. And before creating the model, like before creating the code for you, let me check if there's any existing data models in my data set, which is good because I already have a few. So it's invoking the tool to check for existing BQML models. And it's getting the response back in here as well. So, okay, there are already some models in the data set. And what we then get is the SQL for the BQML execution for the model training. So how the BQML model works as well is it's always verifying first with me, the user, the syntax and the plan for execution. So it will not go ahead and execute any BQML execution unless I say this code looks reasonable and please proceed with the training. And also one other note I want to make here when you're playing around with it, you'll notice that the BQML agent also has the capability to refine itself. So if there's still any errors in here because it missed something from the reference guides, it will fetch the error message from BQML and it will refine the plan automatically for me and then say, okay, this is the error that I found. This is the fix that I made. This is the new execution plan. Is this okay for you? And then I can just either fix it or edit stuff or just proceed with it. All right, so that's the data science agent in action.
That was so fun to watch, Malcolm. So can you quickly summarize what we've seen in this video and give us like maybe 4 to 5 takeaways?
Absolutely. So what you saw today, what we walked through was, we walked you hands-on through how you can set up a multi-agent system, in our case, a data science agent, using the ADK. So if you recall, we had our root agent with 2 agent tools, with a sub-agent, and we're very quick in setting things up, which also leads me to the recap here. I have two. The first one is, you saw that it's very easy to get started with the ADK. So it is modular in nature, and you can just very quickly set up your agents how you need them, following the pattern that we walked through in the code base. And the second thing in here is as well that you can also adjust this very easily to your use case. I mentioned this prior with how easy it is to extend it, but likewise, it's also very easy to just ingest certain modules for your use case. So for example, let's say for your use case, you only want to have the database agent with JSQL because you want to do data Q&A in your flow. You don't need to include all of the rest. You can just import the database agent, connect it to your own root agent, and you're good to go.
And where can we find some resources on this? Maybe the sample agent we just built?
Of course, I'm going to show them in here on the screen. So we'll provide you with the links for the GitHub repository of the agent development kit, another GitHub repository with all of the agent samples that we built, including this data science agent, but also other samples. So I really recommend that you check those out as well. And a few additional links for the evaluation that I mentioned for the BERT SQL eval using JSQL, as well as a short video showing how we used this exact data science agent to train a model using BQML to compete in the Kaggle competition.
And yes, all these links are in the description below. Do check it out. And thank you everyone for tuning in. We hope you liked this video. So we have many more sample agents and videos that's lined up for you. Do check it out and let us know what you think. And thank you very much, Melton, for this wonderful demo.
Thank you, Sita, and thanks everyone for watching.